In this video, we will go over the answer to question 8 of the 2021 New South Wales HSC Chemistry Exam. This question asks, which diagram shows the expected arrangement of soap anions in an emulsion? This is followed by 4 diagrams of possible arrangements for oil in water emulsions, created using soap as an emulsifying agent. The key shows that the grey circles represent the oil droplets, white circles with squiggly lines are the soap anions, and the medium therein is water. To answer this question, we need to remember that the soap anion is made up of an ionic head and a hydrocarbon tail. As like dissolves like, the tail will be attracted to and dissolve in the non-polar oil molecules, while the head will have strong interactions with and dissolve in the polar water, and therefore option D is the answer. We can see this in more detail and eliminate the other options on the next slide. Keeping the options of the question to the side, we'll take a closer look at what the diagrams are showing us. Basically, there are 3 different arrangements of soap anions interacting with oil droplets in the surrounding water. 1, the tails of all the soap anions in the oil. 2, the heads of all the soap anions in the oil. And 3, a random assortment of tails and heads in the oil. The first thing to remember is that like dissolves like, or in other words, polar things will form a strong attraction to other polar things, while non-polar things will form strong attractions to other non-polar things. When they act on their own, water cannot dissolve in oil or vice versa, because one is polar while the other is non-polar. At this stage, we can already cross out the last of these arrangements. To be able to dissolve oil in water, we need to remember that the soap anion has one part of its structure that is non-polar and another part that is polar. This is how the soap is able to attach to both the oil and the water, one part in the oil and one part in the water. In the last arrangement, there is inconsistency between exactly what is attracted to the water and what is attracted to the oil. This eliminates option B from the multiple choice options, the only one that has arrangement 3. Based on inconsistencies, we can also eliminate option A. This contains a mixture of both tail in oil and head in oil arrangements. This is inconsistent as only one of these arrangements is possible. To determine which of these 2 arrangements occurs, we look at the structure of the soap anion. It is made of an ionic head and a hydrocarbon tail. Ions are charged and therefore polar. Hydrocarbons have an even distribution of electrons and therefore are non-polar. We need to remember that the oil in the oil droplets is non-polar, while water in the beaker is polar. Therefore, the head is attracted to the polar water molecules, while the tail is attracted to the non-polar oil. This means the tails of the soap anions will be inside the oil droplets, while the heads sit outside of the oil, attracted to the water, as seen here. Therefore, we can eliminate the head in oil arrangement, leaving us with this arrangement. This eliminates option C and leaves option D as our answer. Here are the references that were used for this video. In Surfing New South Wales Chemistry 7 and 8 by Schell and Hogan, we see the general structure of the soap anion visualized, as well as the arrangement of these anions surrounding the grease or oil droplets. In Chemistry 4th edition by Blackman et al., the general structure is a bit more explicit and includes the countercation in the diagram, and also shows grease or oil surrounded by soap anions in a more 3-dimensional fashion. Thank you for watching and see you next time.